Okay, I hear the recording in progress. Share the screen. All right, so today's pretty much just a review day. I'll do some of my own predetermined problems, and then if you want to ask questions, you may, but otherwise that's about it. Okay, so I'll do my usual spiel. So test tomorrow. Everybody has to join. So again, here, optional. But exam days are not optional. You must show up on the Zoom call. Okay, it's the same Zoom call for the whole semester. Have your name just as on my roll sheet. Camera on, true background. Keep yourself muted. If you have any questions, put them in the chat. I'll send on Canvas announcements the exam, around 9:01, 9:02, 9:03, something like that. And I'll close the Zoom session at our normal stopping time, which is 10. Then you have until 10:05 to take pictures on your cell phone, or if you have a scanner, scan it. And 10:05 for the exam, and then 10:30 for the homework. Although I will take the homework early. In fact, as soon as class is over today, once class is over today, you may start sending me the homework. That'll be fine. Okay. And contents of the exam, 3.2 to 3.6. I usually give about 10 questions, so I guess that would be natural to give 2 each. All right. There is a 70% homework requirement. If you don't submit at least 70% of the homework, I do not count your exam. I'll leave it as a 0. It'll be ungraded. And it should not be that hard to have 70% because I do a great percentage already on the lectures, as you should already know. Okay, if you happen to finish the test early, then you can just leave early and submit the test early and have a good weekend. Okay, this represents the halfway point in the course already, believe it or not. We would have done 3 out of 6. The next exam covers trig. So it's the longest. It's not everything that you had in trig, but it's a great percentage, as you can see. So after today, we're halfway through, but we're not having the next exam until quite a while. Let's see, October the 5th. November the 5th, which is, I guess that would be almost a month away. So we spent about a month on trig. By the way, if that sounds like a long time to spend on trig, remember you probably took a whole trig class, which is a whole semester, right? So rather than doing a whole semester of trig, we're only, quote unquote, doing 1 month of trig, which is still quite a bit, but it's just a review of that. Okay, so we're moving along. We've already reached halfway through the course, pretty much, after tomorrow's test. Okay. All right, and I think those are the basics of exams. Any general questions about the tests, you can ask me or put it in the chat. But I'll do my own review. And then afterwards, if you want to have me do some problem, you may. But otherwise, that's it. I wasn't going to get started with any trig today. I decided not to. Okay, so once I'm done, I'm done. And the part that I have should not take too long. It's probably taking less than half the time. So 20 minutes, 25, 30 minutes, maybe something like that is what I'm looking at. Okay, so let me go straight to review mode of some problems that people asked in the past. Okay, let's see. Problem 27 of 3.3. It's asked for. Let me double check if this is the correct problem, first of all. See if I can get there. Okay, so factor completely if possible. All right, as for the possible rational zeros, the possible rational zeros are plus or minus a factor of the constant, 1, divided by a factor of the leading coefficient, 4. Okay, well, the only factors of 1 is 1. Factors of 4 are 1, 2, and 4. So the possible rational zeros are plus or minus 1, plus or minus a half, plus or minus 1/4. Now, find one solution. If you plug in 1, it's pretty nice. I notice if I plug in 1, I get 0 right away, right? 4 minus 12 is -8, plus 9 is 1, minus 1 is 0. Okay, so it's almost like once I find one solution from a cubic, third degree, I'm down to a quadratic second degree, and then I'm home free. I either factor or use a quadratic formula. So let me divide out 1. Again, 1 means a factor is x minus 1. If you want to, you can put that in your cheat sheet. Okay. Remember, on your formula sheet, your cheat sheet, you can put anything you want, not just formulas. If you want to put sample problems, that's okay. Okay. I mean, I've actually had some students tell me, you know, I put a sample problem on my formula sheet and say, hey, that very problem's on my formula sheet. Well, great. All you got to do is copy it and you're done, right? Okay, so you're allowed to put sample problems on your formula sheet. All right, so 4, -12, 9, -1, 1. I'm expecting a remainder of 0 if I do it the right way. All right, so 4 comes down and multiply, add, multiply, add, multiply, add. Remainder is 0. So how do I read this? Factorize this. One factor is x minus 1, and the other factor is 4x squared minus 8x plus 1. And I don't believe that's factorable, so I can use the quadratic formula. All right, so x is -b, 8, plus or minus the square root of b squared, -8 squared root of 64, minus 4ac, 4 times 4 times 1. If you forget the quadratic formula, you can put it on your formula sheet, although if we were meeting face to face, I'd make you guys memorize it. So, you know, advantage that we're meeting by Zoom is, again, they told us to make things a little bit easier on students. So the one way I'm making it easier on you is to let you have a formula sheet. Okay, this comes out to be 64 minus 16, which is 48, all over 2a, 2 times 4. So 8 plus or minus the square root of 48 divided by 8. 48 happens to be 3 times 16. 16 comes outside as 4. Square root of 16 is 4. 8 plus or minus 4 radical 3 over 8. Factor out the 4 on top. 4 times 2 plus or minus radical 3 all over 8. 4 cancels the 8, giving me a 2. So 2 plus or minus radical 3 all over 2. Okay. So that tells me my 3 solutions. Again, it's third degree. It's a cubic. Cubic means third degree. Cubic. Third degree. Cubic. Quadratic. Second degree. The vocabulary there. Okay, so I know there's 3 solutions. 1, 2 minus radical 3 over 2, 2 plus radical 3 over 2. Then how do I write the polynomial? It's basically x minus each one of these. X minus 1, that's easy. So what if I get a mess like that? It's still x minus that whole thing. So x minus 2 minus radical 3 over 2, and x minus that whole thing, x minus 2 plus radical 3 over 2. Okay. So it's completely factored. And yes, notice the idea of conjugate pairs again, right? Solutions come in conjugate pairs. So back here, there's going to be 3 zeros. Excuse me. Nobody said they'd be nice. So here they are. And here's the factors. Okay, 37 asks for a 6th degree polynomial. This should actually be considered a fairly easy problem, I think. 6th degree polynomial, 0 of multiplicity 2 and x equals 1. A 0, if it's written like that, it means multiplicity is 1. X equals 4. And, oops, I didn't get the wrong problem. 0 of multiplicity 2 at x equals 0, and it's 0 at x equals 1. Okay. So x equals 2 multiplicity 3 means x minus 2 cubed. X equals 0 multiplicity 2, x squared. Remember, x squared is like x minus 0 squared. And x equals 1 multiplicity 1. There it is. Now, you could put a k in front if you wanted to, but there's no need to. That's where, if it says something like p of 1 is equal to 4, then you would plug in to find the k. But they just asked for a polynomial. Here's a polynomial. So that does it. Okay. Okay, let me go back to 3.435. F of 2 equals 0. Okay, that means you have a dot at 2, 0. F of x approaches 3 as x approaches infinity, and also negative infinity. That means y equals 3 is a horizontal asymptote. Y equals 3 horizontal asymptote. As x approaches 0 from the right, f of x approaches negative infinity. F of x approaches positive infinity as x approaches 0 from the left. Something like that. Okay. So I got the graph. Goes through here, 2, 0. Goes toward 3, goes toward 3. Shoots up, shoots down. Okay. This tells me that I have a vertical asymptote at x equals 0. That means x can't be 0 on the bottom. This tells me there's going to be an x minus 2. Okay, but if I look at end behavior, if I only have this, right? I say, what's the horizontal asymptote? I would say x divided by x, which is 1. But the horizontal asymptote is way up at y equals 3. So I just put a 3 in front, coefficient of 3. And that pretty much does it. So 3x minus 6 divided by x should be my solution. Let's double check. Goes through 2, 0. Plug in 2, you get 0. If x is super big, you would ignore the minus 6. 3x divided by x is x. If x is a super big negative, likewise a negative 6 is immaterial, approaches 3. And if I plug in 0.00001, this is a large negative. If I plug in negative 0.001, large positive. So there we go. Okay, I was asked about 41 again. So let's rehash 41. X over x squared minus 3x plus 2. So first I factor into x minus 1, x minus 2. No cancellation. So horizontal asymptote, y equals 0. How do I know? This is first degree. This is second degree. So in the long run, the bottom wins, so to speak. The ratio will be 0. If I plug in a big positive or a big negative, the bottom is so much bigger than the top in absolute value. The ratio is practically 0. Intercepts, 0, 0. Plug in 0, you get 0. And if I set y equal to 0, well, that's going to happen when the numerator is 0. So it touches the origin. And my vertical asymptote, x equals 1, x equals 2. Way out here, approach x-axis, y equals 0. Way out here, I approach the x-axis, y equals 0. And now I do my sign chart. A little bit to the left and right of 1, a little bit to the left and right of 2. So x approaches 1 from the left, 0.99. So 0.99 positive, 0.99 minus 1, negative. 0.99 minus 2, negative. 2 negatives, positive. Y shoots up to infinity. So this side shoots to infinity, goes through the origin, then approaches the x-axis as an asymptote. X
What
approaches 1
number
from the
was
right.
the? Oh,
Go ahead.
I'm sorry. What number was the as f of x approaches 3? What number was that on what assignment?
F of X approaches, well, Y approaches 3.4 number 35. Is that what you mean?
Wait,
That's the only one that I did.
no, it was as f of x approaches 3, x goes to infinity. As f of x approaches 3, x goes to negative infinity. It was the word problem. I just can't
Okay, well, when we get to it, let me finish this, and if you can find it, then ask me at that time. But I just did 35. Okay, X approaches 1 from the right. 1.01 positive, 1.01 minus 1 is positive, 1.01 minus 2 is negative. That makes the whole thing negative. Y approaches negative infinity. All right, so I'm done with X equals 1. Then I analyze X approaches 2 from both the left and the right. So 1.99, positive, positive, negative. That makes the whole thing negative. Y drops to negative infinity. Okay, so it comes down like so, comes down like so. So it must go up somewhere and come down somewhere. It does not come as high as the x-axis, because if it touched the x-axis, I would have found that with my intercepts, but I didn't get any other intercepts besides the origin. So it must come up and come down somewhere. Where is it? We don't know right now. You will learn techniques of that in calculus. So when you take calc, you'll learn stuff on that. And furthermore, I put it halfway between 1 and 2, 1.5, but I don't know that's true either. It might go up, let's say at 1.4 and then come back down, or it might not go up to 1.9 and then start coming down. We don't know that at this stage of the game. Okay, then 2.01 looks like everything is positive. 2.01 positive, 2.01 minus 1 is positive, 2.01 minus 2 is positive. The ratio is positive, Y approaches infinity. So we got the whole graph. Way out here, comes through the origin, shoots up like that. Here it comes up and then down. It reaches some maximum somewhere. We don't know how to do it now. You'll learn that in calculus. And then shoots way up here, and then in the long run, it approaches the x-axis. Okay. All right, and then I was going to do 3.519. And that's the last pre-assigned problem that I have. So after that, you may ask me questions. So you can either unmute yourself at that time or put it in the chat. But otherwise, that's all I was going to do. Okay, f of x equals 1 minus x to the 4/3 minus 1. Okay, first thing I want you to notice about this is it ends up being the same thing as x minus 1 to the 4/3. Okay, in fact, I should actually write it like so. One minus x and x minus 1 are opposites. But if you raise both of them to the 4th power, you get the same thing. So it's easier for me to analyze it if I write it as x minus 1 to the 4/3 minus 1. All right, so in order for me to do this one, well, in order for me to do this one, I have to pick numbers that have nice cube roots. So I picked 0, plus or minus 1, plus or minus 8. Okay, so if I'm looking at x minus 1 to the 4/3 first. Oh, sorry, just x to the 4/3. Sorry, x to the 4/3. This is the table for x to the 4/3, which means take the cube root and then raise to the 4th power. So 0 gives me 0. 1 gives me 1. In fact, plus or minus 1 gives me 1. If I plug in -1, -1 to the 4th power is still 1. cube root of 1 is 1. And then plus or minus 8. 8 to the 4/3 means cube root of 8, which is 2. 2 to the 4th is 16. Negative 8. Cube root of negative 8 is negative 2. Raise that to the 4th power. You still get 16. Okay. So 0, 0, 1, 1, 8, 16, negative 1, 1, and negative 8, 16. So this green graph is what I want for x to the 4/3. And then I move 1 to the right and 1 down. Okay, let's see. Ignore all of this stuff. This was a leftover from the last time I taught it, and somebody asked what happens if it goes down. So sorry, ignore that. Okay. This is x minus 1 to the 4/3. And then just shove it down 1, which I could have done all at one fell swoop, but anyway, too late now. X minus 1 to the 4/3 minus 1. And now that's my final answer. So that's finally what I have right there. Okay. And I think I'm done with everything that I was going to do and some pre-assigned problems. Okay, so I'm finished, folks. So I will let you ask questions now. You can either put it in the chat or unmute yourself for that, but otherwise the rest of the time is yours and where you can ask me stuff. So let me get this ready and let me check the chat. We have a request for 3.6, 51, and 55. 3.3, number 5. Okay. So let me start with that. Okay, 3.6, we just did that last section, right? So 3.6, 51. Okay. So degree 3 zeros are 2 and 2i. 3.651. Zeros are 2 and 2i. All right. And since they gave me this, I automatically have negative 2i. So this was given. I put this in red because that wasn't given, but zeros are always in conjugate pairs. So if 2i is a solution, so is negative 2i. So the polynomial is x minus 2, x minus 2i, x minus a minus, or x plus 2i, which is x squared minus 4i squared, and I squared is negative 1. So it's x minus 2, x squared plus 4, which is x cubed minus 2x squared plus 4x minus 8. So that's my final answer, right? So this is the cubic, 3rd degree, that has these 3 zeros. Okay. 55. Degree 5, a 0 multiplicity 2 at negative 2, a 0 at 0, and a 0 at 1 plus 2i. Fifth degree. So 0, negative 2, multiplicity 2. So that means I'm going to have x plus 2 squared. A 0 at 0, is 0 at 1 plus 2i. Okay, 1 plus 2i means I automatically have 1 minus 2i because they come in conjugate pairs. And that gives me 1, 2, 3, 4, 5. So that does it. So multiplicity 2, x plus 2 squared at 0, which means x. I'm speaking to x in front. And then x minus each of these guys. So x minus 1 plus 2i, x minus 1 minus 2i. Okay, that's 1, 2, 3, 4, 5, fifth degree. Okay, and now the hardest thing is to actually multiply all this junk out. So let's see if I can work it out. X plus 2 squared is x squared plus 4x plus 4. And then you say, how do I multiply this stuff out? Well, I can write this as x minus 1 minus 2i x minus 1 plus 2i x cubed plus 4x squared plus 4x. This is like a squared minus b squared. So that is x minus 1 squared. That's x minus 1 minus 2i, x minus 1 plus 2i. So x minus 1 squared minus 4i squared, and we know that's plus 4. So x cubed plus 4x squared plus 4x times x squared minus 2x plus 1 plus 4 is plus 5. Okay, and now it's just tedious to multiply it all out. But x cubed times all of that, x to the 5th minus 2x to the 4th plus 5x cubed. Okay, now 4x squared times all of these guys. 4x to the 4th minus 8x cubed plus 20x squared. And then 4x times all of these plus 4x cubed minus 8x squared plus 20x, assuming I did not make a mistake. Okay, again, on the exam, show all your work. I do give partial credit. Okay, so if you give me all this stuff, I can follow your logic. So you'll get more points if you can follow the logic, even if you made an arithmetic error, as opposed to if you just give me an answer and I don't see any work. I don't give you much credit for that at all. Okay, so assuming I did not make any mistakes, which is not a safe assumption, but let's just do that for the sake of argument and then make sure I have enough time to do everything. X to the 5th, then x to the 4th are these two, so that's plus 2x to the 4th. And x cubed is that, and that. That's 5 minus 8 plus 4 is 1, I believe. Then x squared, where's x squared is that one and that one, 12x squared. And then just x is plus 20x. So finally, that's my answer. So if I did it properly, this is a 5th degree polynomial whose zeros are -2 of multiplicity 2, 0, 1 plus 2i, and 1 minus 2i. Okay. So that's that. 3.3 number 5 was asked for, and let me check the chat also. 3.311. Let's see what that's about. Okay, now, if I miss your question, because it's hard for me to lecture and look at the chat at the same time, ideally I have somebody helping me that can just answer or just jot down all the questions that are in the chat. But since I'm doing a little juggling act, if I miss your question, go ahead and ask it again, in case I don't see it all. 3.35. Okay, 3.35. Find a quotient and remainder that divided by that. Okay, so that's polynomial long division. You cannot do synthetic division if you have a quadratic that you're dividing by. 2x to the fourth, can't even read this thing. Minus 2x cubed plus 4x squared plus x minus 2 divided by x squared minus x minus 1. Okay. Let's get this thing to focus. Okay. Here and here, 2x squared. Now 2x squared times this whole thing, 2x to the fourth minus 2x cubed minus 2x squared. Subtract, cancel, cancel. 4 minus a minus 2, 6x squared plus x minus 2. X squared into 6x squared is 3. 3 times the whole thing. Oops. 6. 6. 6 times the whole thing. 6x squared minus 6x minus 6. Subtract. That's gone. X minus a minus 6x is 7x. 2 minus a minus 6 is 8. That's my remainder. Plus 7x plus 8 over x squared minus x minus 1. Okay, and then 11. Use the factor theorem to show that x minus c is a factor of p of x, and a factor completely. Okay, so 11. P of x is 3x cubed plus x squared minus 8x plus 4. C is equal to 2/3. All right, so they're saying if I plug in 2/3, I should get 0. Let's actually try it. P of 2/3. And by the way, I think I'm down to the last problem. I believe I've caught up with the problems that you asked for. So if anybody else has any other questions, go ahead and put in a chat. Otherwise, we're done after this problem. So 3 times 2/3 cubed plus 2/3 squared minus 8 times 2/3 plus 4. Oh boy. So 3 times 2/3 cubed is 8 over 27. Plus 2/3 squared is 4/9. Minus 16/3 plus 4, which is cancel, cancel, 9. 8 over 9 plus 4 over 9 minus 16 over 3 plus 4. Okay, this is 12 over 9, which is the same as 4/3. Yes, 4/3 minus 16/3 is negative 12/3. Negative 12/3 is negative 4. Plus 4 is 0, so it does check. All right, 3, 1, negative 8, 4, 2/3. Again, I'm anticipating there to be a 0 here, and then I have a quadratic after that. 3. Multiply. 2/3 times 3 is 2. Add 3. Multiply 2/3 times 3 is 2. Add negative 6. 2/3 times negative 6 is negative 4. 0. Okay. So P of x is x minus 2/3. And left over is 3x squared plus 3x minus 6. Okay, this is not nice, but this has an abundance of 3's. So you can see the next thing to do is to factor out the 3. x squared plus x minus 2. And now distribute the 3. Distribute the 3 over here. So 3x minus 2. And this hopefully is not too bad. X, 1 and 2. Let's see, I want to end it with a positive x, so minus positive. And that should do it. So there we go. Let's answer the question. What is the question? Factor completely? Okay, I factor completely. But if asked for the zeros, in addition, you would say 2/3, 1, and -2. And it's there. Okay. And let's see, 3.219. Time is it? About 10 more minutes or so. 3.219. Use zeros and end behavior to sketch an approximate graph. Okay, negative x squared, x plus 1 squared. Okay, zeros or 0 and -1. That should be pretty obvious. I could consider end behavior, but there's something even better. I'm going to use the fact that I see squares. This is always positive, right? X squared, unless I plug in 0, which I'm not right now. This is always positive. So x squared times x plus 1 squared, I claim is always positive. So what does that mean if I have a negative in front? It's always negative. Done. I cannot have any graph up here. If I did, that means y is positive. But take a look, y can never be positive. Because x squared is positive, x plus 1 squared is positive. The minus sign makes the whole thing negative, except at 0 and -1. So pretty fast graph. That does include end behavior. When x goes infinity, y approaches -infinity. We already knew that from what I just said. And likewise, if x plus -infinity, y approaches -infinity, because no matter what I plug in besides 0 and -1, it's going to be negative. So that is that. Okay, I think I've caught up. So let me stop the share and check the chat, because otherwise we're finished, folks. Okay, anybody else with a question? All right, have a good day. You may start submitting the homework. Get your cheat sheet ready for the test tomorrow, and we'll see you tomorrow for the test. Okay. All right, bye, everybody.